Oh, welcome back. For those who has just joined your mobile community day 3, and it's our last but not least presentation with great speaker who I'm gonna introduce right now. He's engineering manager, Android Studio Canary fan, active KMM user and developer, Vladimir Chernemki. Hi, Vladimir. It's nice to
Hello,
have you
everyone.
here.
Yeah, thank you for the intro, Dmitro.
How do you
It's
feel
also
about? Yeah,
yeah,
go on.
yeah, it's a pleasure to be here to share some experience with the multi-platform with everyone.
Yeah, yeah, that's great. How do you feel about being like the last presenter?
That's really like a great responsibility to have actually, but I hope that the topic will be interesting for everyone and we will have a bunch of questions.
Yeah, that's great. And before we start, I want you to ask a question, like I did to the other guys. So, why did you decide to leave the quiet harbor of Android native development and move to stormy frontiers of cross-platform?
Yeah, that's actually a really good question. So first of all, I'm not really moved 100% to Kotlin multi-platform as it's not like it's moving to the state of kind of replacing most of the native development, but still it's just a partial addition to what we can use in order to share some logic that could be reused between the platforms. And that's basically what I will share about today. So still, I'm really enjoying use of this tool or this technology in order to basically get some code shared between the apps.
All right, all right. Thank you for the answer. And before I give you a word, just want to remind everyone you may leave your comments in VR community chat or here in YouTube chat. Thanks all. Vladimir, you may go.
Okay, thank you for the intro. So hello everyone. As Mitchell already mentioned, my name is Vladimir Chernenki. I'm the engineering manager here in the EPAM systems in the Ukraine office. And today I would like to share some of our experience using the Kotlin multi-platform in production for more than a year already. We've started when it was still in alpha and still decided to apply it, right? So I know that speakers were talking about Flutter today, and the Kotlin multi-platform is not really the like so powerful, let's say, tool to replace the native development. But for those of you who may never heard about it, I hope that there are no such people, but still, the Kotlin multi-platform, and in our case, mobile specifically, it's a technology developed by the Kotlin team that basically allows to write the code using Kotlin, and then thanks to the Kotlin compiler, have some JavaScript, maybe some binaries for some native platforms, and the jar or AR files in order to be used for the JVM. Obviously, as the multi-platform stands not only for, let's say, mobile development, right? There are much more that the team is working on, but today we will focus solely on the mobile with slight bit of maybe some other platform that we will be talking in a bit. So before you will start to use the Kotlin multi-platform in your project, you would need few things to have in advance. So there are even the list of 6 items, but not everything is really mandatory, and I believe most of the things you will already have in place. So as I'm Android engineer in general, I definitely would have the Android Studio or at most the IntelliJ IDEA installed on my laptop. So that's pretty much done for me. For the iOS engineers, okay, you have the Xcode, but you would need to install either or as well. I would recommend the Android Studio as it will be much better fit for you. For Android users, if you would like to build the iOS app in general, as a result, you obviously would need the Xcode as well and the macOS system. The next one is the IDE plugin for the IntelliJ product that is called Kotlin Multiplatform Mobile. The really nice thing, it will basically allow you to have the template either for the application or for the module already in place. So it's much easier. All the configuration will be already in place. And also it will allow you to easier build your app, right? Or library, doesn't really matter. So nice thing. Next, as well, it's mostly for the iOS engineers, but you would need the Java development kit in order to run everything together. And as soon as you will install the IntelliJ IDEA or Android Studio, you will have also some Kotlin installed already, but I would greatly recommend everyone to use the latest one because it also comes with the latest updates to the multi-platform inside. So you would definitely would like to have those. And few optional things. It is the Cocoa Pods. It's for it's kind of like iOS dependency management tool, if I'm correct in the wording. So you will be able to use some existing pods in your Kotlin project. We will talk it in few slides. And the last tool that is provided by the Kotlin team is KDoctor. Basically, the tool is pretty simple. You install it, let's say with Brew, run, and basically it will check for you if everything mentioned in prior 5 items are present on your laptop. So that's about the purpose of this tool. Right, so we have everything in place, we good to go. Let's create our first project, right? And the task, right? So the task in scope of which we will talk through this presentation is to create actually the library, not the full-fledged application, but the module, the library that will help us to share some common logic, which definitely will be shared across various apps, right? So it's for data caching that later can be used in our iOS app, in Android app. And what is interesting here is to have also the Java library for our CI pipeline. Okay, we are all on the same page now, so we are good to go. So the spoiler alert, it will be working. It's working fine already. There are a few caveats, and actually that's about those we will talk through in the next slides, right? Because nothing can be so easily, especially in the cross-platform world. So the disclaimer, we will talk through some challenges that our team had during implementation of this module. We can find a bunch of the same use cases across the globe in the internet, on the Stack Overflow, on the Kotlin forums. So that's basically, to be honest, nothing really new, but still, I would like to share everything in one condensed way. And important to know, most of those issues we had due to some maybe lack of attention during reading of the documentation that is provided to us. And the difference in general is the Kotlin has the versions for native and for JVM, right? And those are quite a bit different. So let's go through some challenges. So the first one, so the Kotlin has no concept of checked exceptions, right? So in Kotlin, all exceptions are unchecked. So whenever might happen in the app, we can live with that, right? But in Swift and in Kotlin native, the exceptions could be only the checked. So let's imagine we have this suspend function for perform some magic, right? And we will throw some exception due to edge case, right? Let's say we don't know how to do this trick. So below you can see the code in your iOS project, right? To execute the same function. So let's say we want to perform magic in our Swift application. Perfect. If you notice, we do have the unit, basically the return value, and the error. So first assumption was that, okay, we will get the error that will be thrown during this function execution, right? I never was so wrong because the app will crash in such case. So in order to prevent that, we have the throws annotation where we should manually declare which exception can be thrown by the function, and only in that case it will be returned in this completion handler. Okay? The main problem here, and it's still present, then during development, nothing will highlight you to do that. So it will be either by reading the documentation of whenever logic you are implementing, or by checking the implementation of the logic that you are using, or, and it's kind of 50% of the use cases that we had, is to try this out in iOS project and declare whenever it's crashing, and basically through debugging, okay? Unfortunately, we still have some exceptions that are missed, and we're trying to figure out what exactly is causing those, because for Android, they are not retro for some reason. So that's the first one. The second one, right? Okay, the app crashed. We added this module to or framework to the iOS application, and let's say we forgot to upload the dsym file, right? Or in general, we do have some unhandled exceptions, or even both, right? As we have here. So in Crashlytics, in the Firebase, you will get something like this abort function. In the best scenario, something unhandled exception, and that's it, right? It doesn't bring any value, and there is no stack trace that can help us to identify what exactly is happening. So besides the annotation that I mentioned before, we can also upload the dsym file, right, to the Crashlytics or any other crash reporting tool. I hope you have. So once that's done, we can get a bit more reasonable crash or crash report where we would have the exception, the message, and maybe in our case here, it was called in this content view body. So the place. It's the most optimistic scenario that you might have, but still, it's something to really remember and read through the documentation. The next thing. So obviously, with all cross-platform solutions, there is a stage when you need to implement some custom logic specifically for the platform, right? And various tools provide different scenario solutions for that. So for the Kotlin multi-platform is not exception. So here we can see some example. In our case, it's for database. As we're implementing the caching solution, we would need the database to have, right? So we have multiple, let's say, source sets, right? For the shared code, for Android code, and in our example, for some JVM code or Java code. So in common code, if you notice, we have the expected keyword in the signature of the class. So we're expecting the class database factory that will accept the application and will have the function create driver. Great. You might think if you can use the interfaces for that, and you will be right, we can, but in such case, you would need to manually provide the implementation of this interface to some place where you need to use it. In here, the compiler will do all the job for us and will basically replace the expected class, which basically kind of template, with the actual implementation. Okay, see, we have the actual keyword, the actual database factory, which actually implements the create driver. And in our case, for Android, it is using the Android SQLite driver with some parameters and uses application. But for Java library, it's using JDBC SQLite driver and having some custom constructor, right? That's the first point. The main minus or disadvantage of this approach is that constructor has to be the same in all cases, right? And in Android, we are using the application, but let's say in Java implementation and in iOS as well, actually, we are not, okay? But what is application, right? In Android development, we all know what is application. But for Java, let's say, it doesn't make a lot of sense, even it's not used, right? In Swift as well, there is no such thing. So application is also kind of example of this platform-specific code. So we're expecting the class application, right? So it's kind of wrapper around Android application, and anything that you can place inside for the rest. And the trick here specifically is to use the type aliases instead of some custom class or data class that will wrap inside this application. We can use this approach, and a lot of things in the Kotlin multi-platform that are provided to us are done this way, actually. So there are a lot of type aliases from, let's say, for networking, there is like network exception, and iOS library implements it or connects it with type alias to another exception. And for Android, it uses another exception. So that's nice to have. Moving forward, fine, we have this expected and actual classes, right? And that's great if we can use the plain Kotlin code and the capabilities that we do have in place. But sometimes we need to have something a bit more fancy. Thankfully, the Kotlin and Kotlin native provides the bidirectional interoperability with the Objective-C and Swift. And even more, the Objective-C frameworks and libraries can be used in Kotlin code. Hopefully I will not be wrong right now if I will say that Swift libraries that do have the Objective-C headers generated can be used as well. But how it's working? So on the left side, you can see some code in Swift that basically returns string with the path to some folder in temporary folder, and if needed, create all other folders by this path. Right, pretty straightforward to store some information. So as we work in with Kotlin, we can't really write the Swift code inside. So for that, thanks to this interoperability, we have a lot of already provided kind of iOS, but with Kotlin aliases libraries for some main functionality in the iOS. So here we have the file manager, right? On the right side, you can see the Kotlin code, which actually will be used for iOS implementation and then will be mapped to the Objective-C code. So let's go through it a bit because there might be some questions to it. So the first line is basically the same, right? You kind of creating the path for it. So the resource dir string is kind of the same, nothing really interesting here. But the next part is really interesting to have because the error is kind of the pointer actually to the error. It's not actually the return type. So the Kotlin provides this memscope DSL that allows us to actually pass some kind of pointer into it and then refer to the error if it will happen. Not all of the code is done in this way, so it won't be too complex all the time, but such cases might appear, and it was tricky to find this actually thanks to some Stack Overflow solution to describe this in a nice way rather than what we have in the documentation. Also, all other kind of primitives, classes are mapped. In the documentation page, there is a table which describes how the conversion works. And yeah, that's basically it. Maybe one last bit to know about the iOS interoperability is that the XC framework or Swift package that you will generate in the end will use Objective-C, which might create some complications to engineers as a result. Next, challenge number 5. Okay, we basically covered the errors. We implemented some platform-specific code. Next, let's actually load data that should be stored in our database. Okay, so for Kotlin, like out of the box almost solution, it will be the coroutines, right? It's the way to run the asynchronous code if put really simply. But in Objective-C or Swift, there is no such thing, right? There are async await, but that's it. And it's not really the same. So Kotlin designers in 1.4 Kotlin decided to convert those into the completion handlers. And by completion handler, I mean kind of the callback that will have the return type and then and the error. We saw that in the example with the magic trick, right? So let's see really basic example here. So if you would have the load data function, the suspend function, and that will be loaded on some default dispatcher, then let's say in the Swift, if you need to call it twice in the nested way, you have to nest the callbacks. Obviously, there is a way to maybe write some wrappers, and there is a way to play with async await a bit, but it's still a bit of an overhead right now. Another important part is that dispatchers for iOS, so in general, you would need the custom dispatchers defined, also with type aliases as an option. Because on iOS, you can't run a coroutine from non-main thread. There is an experimental flag to do so, but it's up to you to try it out, and it could lead to some memory leaks. But in general, let's say if we talk about, there is basically dispatcher's default, IO, and the main. So the main, pretty obvious, we're mapping it to the main queue in the iOS. And for two others, we basically using like async and looper. There are a bunch of examples in the internet with that to basically queue the work, but do not really execute it on the main thread. That's about the coroutines. The next, and actually the last one that we have, remember I mentioned that we also need the Java library that will be run on the CI. So the tricky part, the first bullet is actually the error message that mentions the Java plugin was applied, but it's not compatible with the Android plugin. And that's pretty bad, right? If I want to build the Java library, it's not working really out of the box way. Still, there are solution to it. And the next one is to create the fetch jar. It is described how to do that, but as we are not allowed to use the Java plugin to the full power, it's also the tricky part. So how we approach that? So we still define the target, but usually according to all the examples and tutorials that you have in the internet, so in this JVM block, you will have the function with Java to be executed, and then it will figure the rest out. So in our case, what we did is remove this with JVM or with Java block. It started to work for Android without complaining because the only line was complaining. Then we have to create the fetch jar, right? So the only way that at least I've come through is to take all API, all dependencies that defined with the API from the common code, zip them, and then take all the libraries that are needed for the JVM, or yeah, for JVM target, zip them, and then merge together. Plus, define the duplicate strategy to exclude the duplicates, and it's working fine. No crashes. The only issue that we had, so we are using Ktor for network requests, and for Ktor, you basically providing the dependency per target for some custom implementation. So as we had both Android, or sorry, the common and the Java dependencies, the packages there are different, and the Ktor basically searches through the class paths and taking the first one. So the problem was that it was taking the wrong one, so we basically removed one or sorry, not removed, but we defined what actually implementation we are expecting, because it's also a possibility, and then it started to work fine. That's basically it, right? So enough about challenges, right? Because it would seem like it's too bad to work with, right? But still a lot of different companies applying it and working with it, right? So why is it so? What a result that we got in the end? So let's recall the scope, right? We need to do the network calls, the database interactions, and some resources loading. So that's usually the code that you write once, and don't update so often, right? You should work on the business logic and that's it, or UI updates. But this part is not updated so frequently. So what we won? We won about 2% of the code base in general from what we have. So at least right now, 51% of the total lines of code is on iOS, 47 is on Android, and 2 is the shared code library. I would definitely say that, let's say it's 2% right now, but if you would write this code 3 times for different targets, then it will be much more reasonable, right? If not looking into this. I will not mention the lines of code specifically, but at least in the percentage that what we have right now. But also we're looking forward to try out to create few other modules that that are not updated so frequently. The build time. So that's the problem. To be honest, at least in the way how we are building the framework for iOS. The small disclaimer that we are using the custom plugin from 2021 that allows to build the Swift package. And there is official solution that we are not using, at least for now. So that's the numbers. In average, from the 3 runs, 3 different use cases. So the worst one, when we have the clean build, the cold Gradle, because you are building it with a Gradle, it's like, for me personally, it is how many? 6 minutes, right? 6 minutes on the M2 MacBook with 16 gigs of RAM. Great. For Android, it is 44 seconds basically. You obviously will not have this use case a lot. It's basically the very first time you will build something. The next one, right, is when you still have the clean build for some reason, but the Gradle is already running for quite some time. Then you will benefit about a minute for iOS, and even more, it's like about 15 seconds for Android. And next, the most common use case, right? When you make just a single or multiple lines of code change, you will get like almost 3 minutes for iOS and few seconds for Android. That actually brings to really important conclusion that ideally you should develop like Android first, which usually not the case, and then apply the same code to your framework to the iOS and just verify if it's working as expected. I know that I briefly tried the latest solution on how to build the frameworks for iOS, and it was working faster, but I don't have the numbers at least right now. Maybe at some point in the future, I will share the new numbers to those who are interested. So, okay, we still decided to use it, right? It's not concerning us. It's the module that is built like once, I don't know, we making the change to it maybe once a month, maybe once in 2 months at most. So that's why it still works for us. So it's a single source of truth. The code is not changing so often, so we don't need to rebuild it like every time. So that's fine. Next. So what about the iOS devs, iOS team? So can we get rid of them, or we still need them? What's going on? So I would say we still need them, right? Because there are edge cases that still should be covered. But to answer on the question if iOS engineer can write or contribute to this module, the short answer is yes, and we have the example of Nikita from our project, who can write the code, right? So the Kotlin and Swift are quite similar in general, and it's not as performant and fast as to do the same in Swift for iOS engineer, but in general it's possible. In the worst case, you would need to get into documentation, maybe some Stack Overflow, and find out what's going on there, right? But it is possible. It's more question to the engineers whether to do that or not. So, few tips and tricks from my side if you decide or maybe considering this. So, especially at the very beginning, I would suggest to keep it in the same repo, right? Especially, well, let's say you have the Android team, which may be considering to use multi-modules with Gradle, or maybe already have done. So to identify some code that is not changing frequently, maybe some core library or something like that, that it still can be used across various applications, and apply the multi-platform plugin for in Gradle, update the build script a bit, and that's it, right? For Android, it will be still the module, the Gradle module that can be used as is, or almost as is. The main point is to have the libraries, right? That is used as there as well. And for iOS, it can be built and tried in general by the team, whether it is working fine for them or not. The next point is to really carefully read the documentation, especially parts about the error handling and the synchronous operation, right? I missed that a bit, so paid for that, but still, that's resolvable. And the last but not least, start at least or try it out. You might like it. Hopefully you do. And in general, few recommendations from my side, some battle tested libraries. There are not much of them. That's the disadvantage of this tool, of this technology right now. But there are companies like the IceRock, the TouchLab, that really investing into it a lot. So there will be more, right? So those that are the most useful in our case, it was the Ktor for the networking, the SQLite for the database, then Napier, it's for logging. It's really similar to what we have in Android for as Timber. And the Crypto, it's basically the library that has a lot of encoding, decoding algorithms that are implemented in some native ways. There are a few more, but they are minor. And in general, if you're considering to use or move some module into the multi-platform module, check what dependencies you are using there, because if there are a lot of them that are not available in some way or another for multi-platform, because it should have the implementation for all your targets that you have, then maybe consider some other module, because you would need to create a lot of actual or expected actual implementations that will reduce the purpose of this to share the code, right? So that's basically it from my side. I hope I still have like 10 minutes, if I'm not mistaken, to answer all your questions. So, Dmitry, do we have any?
Thank you for your presentation. That was actually really nice. I really like Kotlin multi-platform. Maybe somebody should try, and I will try it one day. And we actually have questions from the auditory. So the first question, what do you think about Compose multi-platform?
Yeah, so that's really good question. So briefly, in general, the Kotlin multi-platform right now is in beta version. So it's not released, but it's like on the way to become the released in some nearest future, according to the Kotlin team. And yeah, they've added the alpha version of the Compose. And there are a lot of conversations right now around that. Personally, I haven't tried it, but I think that it makes a lot of sense, especially that both Android with Jetpack Compose and iOS with Swift UI is moving towards the declarative UI. The main challenge I see that the Kotlin team might face is like the consistency that that is required, right, in order to write the UI once and reuse it across multiple platforms. So that makes sense, but it will be much more trickier than just share the business logic. That's my take on it.
All right, cool. Thank you for your answer. And the other question is, if looking back, would you still use KMM? Maybe some other approach, Flutter, for example?
It really depends on the need, right? Specifically in this case, with this task that we were talking about, the Flutter will not be a use, right? Because we also have to have this CI library. If you would use Flutter in such case, then there is still a need to create some separate code for this specific use case. But in general, the Flutter, I would say, is a bit more mature in order to use for the cross-platform. Still, we're talking about sharing the code between native apps, at least right now, right? Because Compose may change it in a bit. And it's much more easier to use the multi-platform when you already have some thousands lines of code written in native applications, and you want to move to the direction to share some code between those, right? Because with Flutter, it's basically the journey from the beginning. I'm not sure if you can attach some Flutter screens in Android or iOS app or vice versa. But yeah, that's just a different use cases to consider.
All right, cool. Thank you for the answer. And actually, I would love to ask you one more question for myself. So, are there libraries available for the shared usage?
You mean for like in shared code?
Databases, dependency injection, something
Yeah.
like that.
So I mentioned a few of them on like the last slide. So it's Ktor for networking. Then it would be the SQLite for the databases, for SQL database. There are also some libraries for non-relational databases. Besides this, yeah, there is Coin for dependency injection. What else? For serialization, there is out-of-the-box Kotlin solution, Kotlin library for that. What else? Do you have something specific in mind? But
no, actually, that was an answer. Actually,
yeah, there are not much of them. That's unfortunate. But that's why I mentioned to check first if you need to write some shared logic, if there are all dependencies, or if you need any dependencies that are available, right? Because it might be tricky to work with in such case. And actually, that's additional reason why I think Compose for Kotlin multi-platform would be tricky to share, because even right now there are not much libraries for Jetpack Compose or the Swift UI with some available UI, and we're talking about the Kotlin Compose basically, that even one higher level of abstraction. So yeah, that's the disadvantage of this.
And what about the community? Is community big enough to support all the needs?
It's growing, right? And especially if, let's say right now it's in beta version, and there are already companies, people that are interested in it. As I mentioned, there is Ice Rock and Touch Lab company with the huge set of libraries from them. Obviously, there is the Kotlin forum available. There is the Slack organization for Kotlin that you can sign up into. There is the multi-platform channel inside. And in EPAM, we also have the Kotlin multi-platform channel in the competency center teams. So yeah, I would say it's growing. There are people who are using it, who have the experience with it. So that's pretty promising.
All right, cool. That's actually nice. Thank you for the presentation. There are no more questions to you.
Thank you.
It was a nice one. And thank you one more time for taking your time today. Thanks all for attending this conversation as well. And don't go away. There would be a quiz just in a few minutes. We're gonna check what you know and what you heard today. Thank you and stay tuned.
Bye.